Okay, so thanks for bearing with me. Can you all hear me okay? Excellent, great. So welcome to my talk on managing state in React applications using RxJS. So, hello, I'm James. Be surprised if I wasn't. I'm a developer who works with various technologies and languages, but primarily JavaScript and C#. I've gained experience at the likes of Trainline, Channel 4, Sky, News UK, and Net-a-Porter. I love open source software, writing, speaking, otherwise I wouldn't be here today, and mentoring. And I work at a company called YLD, and we're a software engineering and design consultancy. And technologically speaking, we specialize in JavaScript, and that extends to TypeScript, Node, React, but we tend to do some DevOpsy stuff on the side as well, and we're trying to expand into different tech stacks too. So just a couple of things before we jump in. Firstly, I've been ill throughout the entire conference, so I haven't been like hiding from you and being antisocial. So if I start coughing or having to like blow my nose mid-speech, then I apologize in advance. And as Oswald's mentioned, this is my second time back, this being the second ever FrontCon. So I just wanted to thank the organising team for the opportunity. Yeah, exactly. Like, it's been a great event. Like, you know, I'd be surprised if it weren't, but yeah, you've hit it out of the park, so thank you very much. Okay, so time for some background. Recently, I have been contributing to a web app. On the client, it uses React rendering for the DOM, Redux for state management, RxJS for reactive data transformation and aggregation, and Redux Observable for expressing Redux actions, async Redux actions specifically, using RxJS. Well, that sounds like a lot to juggle, just looking at that list. How does that even look? Well, I'll show you, but we should just take a step back first of all. What even is RxJS? So, RxJS is a library for functional reactive programming using observables to make it easy to compose asynchronous or callback-based code. And that's a quote from the RxJS official documentation, so, you know, I'd go with that. Okay, but how do those words translate into actual code? Well, let's take a look at a simple example I cooked up. So, I should clarify I'm using TypeScript here, and that's because I want to demonstrate the shapes of the objects my sources are emitting, my observables. So, in this example, I'll show you later how you can create your own observables, but RxJS will give you some utilities or creators where you can create observable streams from existing sources with single function calls. In this case, we're using the WebSocket creator. So here we pass it the URL to a WebSocket connection, and what will happen is it will connect to a WebSocket internally, and the observable returned by the WebSocket creator will emit whenever the underlying WebSocket receives packets of data. So notice after we create the WebSocket observable, we use this pipe method, and now this is common to all streams. And what this allows us to do is, as we receive emissions, we can use operators, in this case map and scan, to apply transformations to them in a left to right order. So we're using two operators in this example. The first one is map, and what map allows us to do is it allows us to take a value that's being emitted, return a non-observable value, and it will automatically wrap it as an observable for us. So whenever you're doing mapping and you're going into the next operator, it needs to be an observable, you see. So rather than create an observable of that message, using map will just do that out of the box for free. So looking at stream message, we get a username property and a message property. We're just using destructuring to pick the message out. And now the second operator, which looks a lot more interesting because it is the scan operator. And you can think of this as being analogous to array.prototype.reduce. So it takes two arguments, the callback, which we'll discuss in a moment, but we have a second parameter, which is the initial value, much again like you have in array.prototype.reduce. In this case, we're just defaulting into an empty array. And what scan does is it will accumulate values over time. So as you emit, you can take what you return, and you'll have access to that via the messages parameter in this case, in the next emission. So all we do in scan is return a new array with each time with the existing messages and any new messages we've received as well. And there's one more point of interest I really want to highlight, the subscribe method at the end. So the power of observables, apart from being declarative and functional, lie in their lazily evaluated nature. So we can establish all of these chains of pipeable operators, but until there is a single subscriber, we're not going to be doing any of this computation. So this actually allows us to define all these operations without much computation and doing the nitty-gritty of what we need until we have a subscriber. Now, how does this actually look as it emits? So RxViz is a really cool website for this, by the way. It takes RxJS, and it augments it so it will generate these diagrams for you. So what's happening here is this is what a render message the subscriber will receive, and on each call, on each emission, we receive all of the messages accumulated because we're using the scan operator. So first we'll have hi, then hi, hey, hello, and then yo, keeping it cool as well. So over time, because we're using scan, we accumulate all these values as we continue to emit. Well, let's take a look at another example as well. So this time what we're doing is we're using RxJS as a means of declaratively and functionally transforming a click event. So you have the from event creator, which takes any event target, and it allows you to listen for a certain event. And when that event fires, as you may have guessed, the stream emits. So in this case, we're getting a reference to a submit button on a form, and we're using from event. We're passing submit button as the event target, and we're passing click as the event name. And what we're doing here is using pipe and subscribe. Whenever load story emits, then first of all we're using the switch map operator, which, so as I said previously, map boxes into an observable for you. Switch map doesn't. So what we're doing here is we're using the concat creator, which takes multiple inner observables, and when you subscribe to the outer one, it invokes them sequentially. So what will happen here is we'll have two sequential AJAX calls. So it will make a call for the story data via this hypothetical API. Once that resolves, it will step into the map. And then after that's mapped and the subscribers received it, then it will fire off the second AJAX request. So again, you're able to do really powerful stuff declaratively and well abstracted, and you're able to do so lazily. But just to clarify how the flow of that actually looks. So in RxJS land, this is what you'll call a marble diagram. So it shows how you take streams and their emissions and you compute them into new streams as a result. So what we have here is the from event stream we're creating with a from event when the user is clicking the submit button. And we're using switch map to convert this into a new observable using concat, which in turn is consuming two inner AJAX observables, or observables created using the AJAX helper. So we get one stream, but we get two emissions. And notice here as well how, as I was mentioning, because these are sequentially emitted, you'll emit the first one, the first AJAX response, and then we map. But then we won't fire off the second until the first has been mapped. So it's a really nice way of not only transforming data, but specifying when things in the flow of control should happen. So I can generate, consume, and map streams of data with side effects using composable operators. Yeah, it's pretty cool, isn't it? And as I mentioned, you can also write your own observables. So what we have here in this example is I'm essentially re-implementing the WebSocket creator. Now, if you notice my create message source function, I'm returning a new observable. And within that, I have this callback that receives an observer. And what the observer allows you to do, the observer allows you to push values to subscribers of the outer observable. So in this example, I create the WebSocket. In RxLand, anything that produces values pushed to observable subscribers is what you call a producer. It's just a common terminology. And when we've created the socket, we do things like add event handlers for when you receive a message. You call observer.next, so anything subscribed to that observable will receive that packet. When the socket closes, we call observer.complete, and this will put the observable into what is called the complete state, which means that it's no longer going to receive any data, no more emissions, so it's done. And then there's also an error method, and you can use certain operators such as catch error, and you can handle errors separately to regular emissions, so that's quite a powerful and I guess needed capability too. And then also you can use this add method. The name's interesting, maybe you can perform other side effects, but at this level it allows you to perform cleanup logic, in which case I'm just nullifying the event handlers I've specified with the on foo shorthand, and then we actually close the socket as well. And now this is two things. Foremost, it's called a cold observable because its producer has not been instantiated yet, so we create a new producer whenever we're creating the new observable. And it's also unicast, and what this means is that each observable has its own producer. But for a WebSocket, it doesn't really make sense to open all these connections, and that's going to perform absolutely terribly, and the browser's going to hate us as developers. So what if we did it like this instead? So it's very similar code, only on the first line we're creating the new WebSocket, and when we create these new observables, we are using the same WebSocket for all of them. Additionally, I'm using the add event listener and remove event listener methods, and this is of course because I don't want to override any subscriptions to that socket that might be active. So this is two things again. So hot observable, because you have a producer that's already instantiated, so it's it's almost immediately going to receive new values that the WebSocket emits. But it's also multicast, and that means that a producer is shared across multiple observables and multiple subscriptions. Okay, that's good and all, but what if I need to push data to subscribers from elsewhere? Well, Rx has this concept called subjects, which are observables and observers in one lovely API surface. So it looks something like this. So almost similar to the WebSocket example that I showed at the beginning, you'll notice that we are calling the next method it provides, and we're just pushing hard-coded object references we create. Now, I think I would prefer to use the observable and internal observer approach, because potentially this is kind of breaking that abstraction a little bit in my opinion. But there are cases where you might nonetheless want to push from some external place and share a reference to this subject. And if you do need to do that for whatever reason, then I think this approach is the way to go. And as we'll see later on, there are different examples of subjects that are provided as well. Okay then, so how can I consume observables in my React app? That's what you all came for today. So how about Redux Observable? Okay, so this involves Redux, I know. Okay, so say we have this hypothetical Redux state. So we have an application state where we're holding messages, we have a loading property, and we have a Boolean property to determine if the app's in an error state. And then we also have an action for adding messages to the state, and that contains messages as a payload, so it's an array of strings. And the reducer is just like any old Redux reducer, so this middleware doesn't impact reducers per se. So I should add I'm using if statements here, and I'm using this isAction of type method, function rather, and that's just because it's a TypeScript type guard. So in the second condition, I can guarantee at least at compile time that the action has a messages property. But you can think of this as just being analogous to the switch statements you might otherwise be used to. So it's the very much current state and action in, and then new state out as a result. So there's nothing different there. But then we have this entirely new concept called an epic. I love that name. What an epic does is, this is specific to Redux Observable. So it takes in an observable stream that emits Redux actions, and you return an observable that emits Redux actions. So it's actions in, actions out, and it's pretty much analogous to Redux Thunk. So what's happening here is we're taking in an observable that emits actions. We're using the filter operator to filter for the fetch messages action. So the switch map operator below won't be invoked in any way if it's not of this type, but in our case, let's say it is. Then we're using the concat operator to sequentially dispatch. Foremost, we're going to dispatch the request messages type, which will put our app into a loading state. And then we're using the Ajax creator to make a call for, say, our application's messages, making a HTTP request. And then we do some mapping to pick out those messages. And then we emit the receive messages action with the messages type. With the messages that were received. So then we can handle these in our reducer accordingly. And we're using the aforementioned catch error operator to dispatch a fetch error action if there's an error with the call. So you can think of this as being similar to Redux Thunk, it's just in observable land. And how do we actually hook this up? Well, it's just like any standard Redux middleware really. So it's called Create Epic Middleware. Again, I love the name. So you create this Epic middleware, and then as you're creating your store, your Redux store, you apply it like any other action. And then I'm just hard coding an invocation of store.dispatch for the type fetch messages, which will just bootstrap the app state. Great. So I can use RxJS to control my Redux state, with which I can render a React application. Not bad. But I have to use it alongside Redux and Redux Observable. What if I could just use RxJS for everything? Well, I tried just that. Let me show you. And disclaimer, it's a proof of concept, so try not to throw things at me just yet. Okay, so time for a live demo. So yeah, I'm not going to show you, I've got the code in slides, but I'm just going to start the application from here. Okay, now if I go back to the browser. Okay. Okay, there we go. So I'll zoom in a bit as well. So as you can see, it's the most complex application ever written. So we have a few components of interest. We have this status component essentially, which tells us how many messages we have. And then we have a form for adding messages. And then we have this button for adding once and quotes. So I don't know if anyone here watches Parks and Recreation, the TV show, but it's essentially an API I wrote that so I wrote a HTTP API that returns random quotes. So I'm just calling this in this application to demonstrate its asynchronicity. So you have things like validation states. Of course, it fails because you haven't entered anything. Let's say hello FrontCon. If I can even type hello FrontCon, then it adds it to our messages state. And now if I make a call for add run on the Swanson quote, creativity is for people with glasses who like to lie. Yeah, true words have never been spoken, right? So yeah, that's a whirlwind tour of an extremely complex application. So, okay, if we go back to the presentation. Okay, there we go. Okay, well, how does this actually look? So here is our app component. So this is rendered by our entry point. This is what renders at the top level. So we have 3 components we're rendering. The status component, the number of messages, the message form for interacting and adding messages to the app state, and the message list, which just renders the list of messages. So in terms of reading the state, let's look at message lists then. So we are taking the messages in as props if we ignore the last line. And this is simply a UL that maps the messages in state to an LI, and it just renders the text of that message. But then how are we actually hooking that up to the RxJS app state? Well, you might have noticed this last line, connect to observable. It's a higher order function that allows you to pass in an observable stream, and it will render the component you've passed in the return function when you call that with all of the properties from the state. So before we go into the implementation of that HOC, let's just refresh ourselves with the app state. So it's similar to the dummy one I showed you before. You have messages, you have Boolean properties to determine if it's loading a quote, if the quote fetch has failed, and if the form itself is valid as well. And then we just provide it with the default state as well. And then we have this, do I highlight? No, I don't. So we have this final line here. So we export an app state binding, which is a behavior subject. Now going back to what I said previously about having specific subjects, a behavior subject, when a subscriber subscribes to it, it will automatically receive the latest value that has been emitted. So if you subscribe, you always get a value emitted. That's just something that comes out of the box. So how does this higher order component work? Well, we take in an observable and the default state, as we saw in the message list component, and then we return a function that takes the component, and then we return an entirely new component that takes in props. And we're using React hooks here. Like, I won't go into that too deeply because that's not the subject of the talk, but Manjula did cover this as far as I'm aware in her presentation, so hopefully you have some kind of intro. But to summarize, we use the useState hook to hold the state received from observable emissions internally to the higher order component. And then we use React.useEffect. And what we do with React.useEffect is, so it takes a second parameter, which is an array of effects or values that should trigger a re-render. But what you can do is you can specify an empty array. And what that means is this logic will only invoke in 2 places, or in 2 instances, when the component mounts and when the component unmounts. Well, I say that, but we step into it when the component mounts. So we subscribe to the observable, and that will set the state of that component using the setState function returned by the hook. And then we return this anonymous function from the useEffect callback, and that will unsubscribe from the observable when we unmount the component. Okay, so reading state is cool and all that, but how can we actually go about updating it? So let's take a look at our form component. So when the user adds a message to the state, one they've just typed into the form, we're just using a non-submit handler to invoke what is an add message action. So We hold the current message in the forming state. That's in React-line what you call a controlled component. And we invoke add message, but then we also invoke that within a nested call to next state. Now I'll go into this more deeply, but you can add message is an action, but you can think of to next state almost as a dispatch of sorts. So how does to next state look? Well, you see this first parameter, reducer. So if we just go back, so add message returns a function that's essentially a reducer that takes a state in and you get a new application state according to that action. So we invoke with state, we get the latest value, it's a behavior subject anyway, from the app state, but we switch map and whatever reducer we've passed in, so the reducer function returned from add message, we invoke that, and then we create a subscription where whenever it receives a new state, we're then updating the app state accordingly. And you might be wondering why with state is exported separately, but I'll get into that shortly. So let's have a look at this action reducer concept then. So here's what add message looks like. So it takes a message in as a parameter, and then that returns a function that takes the current state, so that's the reducer. So what I'm doing here is I'm using of to create an observable that emits a one-time static value, which in this case is the new state. So I'm spreading the current state into it, and then I'm setting properties like, is the form valid, is it loading a quote, is there a quote error, which in this case, it's because the user's added a message or the fetcher succeeded, so no. And then we spread the existing messages. So in that case, you're probably wondering why this overhead? Why do reducers have to return observables? And well, that's the whole point, so we can express asynchronous effects. So looking at when you add a Ron Swanson quote, pretty much analogous to next state, and you're invoking a nested call of add Ron Swanson quote within that. So what this does is, now this, although the action doesn't take any params, and we're not reading the current state parameter, what add Ron Swanson quote does is it uses the concat creator, and by using with state, we're able to update the app state behavior subject accordingly. So we trigger the onQuote loading state, which causes the button to be disabled. And then we make a call to the Ron Swanson quotes API, which we then pipe into the add message action, which actually adds it to the in-memory array. And then if there's an error, we set the quote error state. So it will say something along the lines of quote couldn't be fetched at this time. So just to clarify, we could take the state in as a parameter of the function that's returned, but this just allows us to get the latest state at each stage of the flow. So that means we can use the same paradigms to create and query data sources, combine said sources, reduce actions into a single source of truth, and consume this source of truth in React. But you probably, I think a few of you might have considered this by now. How does this actually perform compared to Redux? Or when I say Redux, I lie slightly, I mean the use reducer hook. So to summarize, use reducer is like the use state hook, only it allows you to handle Redux style reducers and actions that update a component state as a result. So you might see more and more as time progresses that people move away from Redux, and we're using this hook with context to pass it down the tree. But I use this as a basis to comparison because it shares most of its implementation with Redux anyway, and I'd already written the comparative application to use this. Well, in terms of average heap allocations, of course, use reducer uses, the y-axis is megabytes, by the way. It uses a good megabyte less. But funnily enough, the actual increase in memory used was consistent across all times, which was interesting. So nonetheless, the observable approach does use some more heap allocations. But really interesting is the flame graphs. So this is for use reducer, And what we're looking at here is when the user adds a message, not the once and query, but when they enter a message into the form and they click add message. So you'd expect this from React. There's a lot of stuff pertaining to fibers and batching of work, and then actually calling the use reducer hook and updating component state as a result. And if we zoom into this particular portion, which is when React handles its submit event internally using its own eventing model, we see the add message action creator is called. That action is dispatched, and then this root at the end is root reducer. So it just goes into the reducer. So the call stack for that particular updating logic is extremely minimal. On the other hand, with RxJS, now the time within that handler is a couple of milliseconds more, so it's not too drastic. But if we zoom in a little bit, you notice these call stacks get quite interesting. And yeah, there are a lot of these deep invocations of next. So we are generating quite large call stacks with this approach. And as I said, this is a proof of concept, and it's something I'd like to tackle, and I have some ideas. But yeah, at the moment, for perf, you're better off with Redux or just use Reducer or just React directly. So we are potentially hampering performance, that's true. But then someone hypothetically pipes up, how do I go about ditching Redux? I like observables now. Well, you probably shouldn't, to be honest. RxJS can be overkill for simpler applications, as admittedly Redux can, but especially Rx. Plus Redux does provide a solid opinionated architecture. And then someone else pipes up, oh James, isn't MobX built around the concept of observables? Why can't I just use that? Well, I will say MobX is awesome at what it does, and I think it does provide a great paradigm for querying and updating state. But just bear in mind, these observables aren't RxJS observables. They're a basic means of receiving state updates. So they lack a lot of the operators. And that's fine because that's not MobX's intention. And there is a means of interoperability. But just bear this in mind if you're going to go down that approach. So to summarize, RxJS provides a functional declarative means of consuming and aggregating data sources. A Redux observable is nice, but we can cut out the middleman using higher order components and hooks. However, Redux provides a positively opinionated architecture. And then also there are performance concerns, so how does it actually compare at a more scaled level? And I want to leave you with one final thought before I open the floor to questions. So Dan Abramov tweeted this, and I thought it was really relevant to this talk. So I think React's ability to handle any input observables without wrapping them... I think React's ability to handle any input objects without wrapping them into observables, wrappers, or trackers is significantly underappreciated. And that's what I've tried to do with the connect to observable higher order component. So although there is some kind of stateful logic to connect to the observable and manage that subscription, by separating it in this way, the actual presentational components like message list are just taking props in and returning DOM trees and subtrees out. So I think that's really worth bearing in mind. Okay, so yeah, you can contact me on these links. I'll tweet the slides and repo out later, but there are the links. So yeah, I'm happy to take any questions. Thank you.
So what potential benefit do you envision from this approach?
So I think so the application on which I was contributing, which I could have covered more, was like a real-time app where I had like these numerous WebSocket connections that were all from different vendors. They all had different data formats, but I wanted to normalize them into a common approach, and the front end was a React app. So we did use Redux Observable in the end, but I did consider, do we even need to use Redux and Redux Observable? So I think for larger scale real-time applications, or at least something where you're aggregating many data sources and you need to combine that into one thing, it's a perfect fit. I mean, of course, the application I show today is extremely simple, and I wouldn't even use Redux for it. But of course, I don't want to bog anyone down with too much detail. Nonetheless, those sorts of larger event-driven or real-time applications would be the use case for me.
I think everybody's running to the lunch.
Yeah, I can't blame them. I'm getting hungry as well.
Thanks.
Thank you. Cheers.
Redux